Hello and welcome to today's lesson where we're going to look at motion graphs. So in today's lesson, which forms part of the GCSE separate science physics course for AQA, we're going to look at the motion graphs and look at how to construct and analyse velocity time graphs, which links into the forces topic which is found in paper 2 of the separate science course. So if we're successful and we learn in today's lesson, we can define what we mean by velocity, we can describe in both words and in mathematics what acceleration is, and then finally we understand how to construct a velocity time graph and how to interpret it. So in today's lesson we're going to look at the following part of the specification. So we're going to focus on the velocity section of the forces module, and we're going to focus on the acceleration part of the forces module. So we can show how the velocity changes in a journey with the velocity time graph. Now these are graphs where the velocity is placed on the y-axis and the time is placed on the x-axis. Now let's have a think. Can we work out what the gradient of this graph would represent? Now remember, the gradient is always the change in the y value divided by the change in the x value. So because we know the y value is velocity and the x value is time, so the gradient is velocity divided by time, which we call acceleration. So the gradient of the graph is shows the acceleration of the object. So the gradient of a line of best fit, in a velocity time graph is the acceleration of the object during that journey. Now a velocity time graph can illustrate the velocity and how it changes in a graph. So again we plot the velocity on the y-axis and the time on the x-axis. Now the gradient shows the acceleration of the object. Now also remember, in this graph the line is made by joining plot to plot as it's showing the journey of an object. So you're not looking for a trend, so you don't have to draw a line of best fit. Rather you can go from plot to plot to plot to plot because it accurately represents the journey the object is under. Now if an object is changing its rate of acceleration, well, the line of a velocity time graph will be curving as shown like this. So if an object is changing its rate of acceleration, its acceleration at a particular part of time, its instantaneous acceleration, can be determined by drawing a tangent and measuring the gradient of the velocity time graph at that particular point in time. So remember, a tangent is a straight line that touches a curve at a point, but if extended, does not cross at that point. So for example, here is the tangent at 10 seconds on your velocity time graph. So again, to work out the gradient of a tangent, similarly you work out the gradient of a line of best fit, you draw a gradient triangle on the tangent and then do the change in y value divided by the change in x value. Now, we can look at different sections of a velocity time graph and understand the different types of motion. So if a line has a constant gradient upwards, it's a straight line going upwards, it must be constantly increasing its velocity, so it has a constant acceleration. If the line is flat, the velocity is not changing, this means it's maintaining the same velocity. Now an object will only be stationary when there's a flat line along the x-axis because it'll have a constant velocity of 0. In this particular example, it has a constant velocity, but it is still moving because the line is not on the x-axis. Now, if the line has a constant gradient downwards, well, then it must be constantly decreasing its velocity, so the object has a constant deceleration, and then if the line is below the x-axis, it means the object has a negative velocity because a negative in a vector form, such as velocity, means the object is traveling in the opposite direction. Now, if we calculate the acceleration of an object and it's negative, it could either mean deceleration or it could mean an acceleration in the opposite direction. You can't just know from a number what it is, so what you'd have to do is either look at the velocity time graph and see what that negative value represents, either line going downwards or line below the x-axis, or you could look at the object's motion in real life and work out what's going on. Now, we can also consider it if it's a curve, because you can get curved sections for your velocity time graph. So what do we know? So like we said before, if it's a straight line going upwards, it has constant acceleration. If it's a flat line, it has constant velocity. Now, if the line is curving upwards, this shows the object is increasing its rate of acceleration, whilst if the line is curving downwards, it's decreasing its rate of acceleration. Now, just like we mentioned before, unlike on a distance time graph, the line can be drawn downwards as the velocity can decrease in a journey. You can, in fact, slow down. And again, unlike a distance time graph, the line can be drawn below the x-axis as it indicates the object's moving in the opposite direction. Now, we can do this because velocity is a vector, so it can have a negative quantity. Speed, being a scalar, cannot have a negative quantity because you can't have a direction with your speed. Okay, and it's the same for distance. Now, in the previous task, we've used the word acceleration. Now, again, we use the word acceleration a lot of the time in everyday language. But what do we mean by acceleration? How can you calculate acceleration? What are the units of acceleration? And what causes acceleration? Well, acceleration is the change in velocity over a certain time. A velocity is both a speed and a direction. Okay, so an acceleration is either a change in speed or it's a change in direction. So you can accelerate either by changing your speed or by changing your direction. And acceleration, like velocity, is a vector quantity, so you can have a positive acceleration and a negative acceleration because you have a direction with your magnitude. Now we can calculate acceleration with the following equation. That acceleration is equal to the change in velocity divided by the time taken. Now we can also write this in a different form because we can work out change in velocity because it's the final velocity minus the initial velocity. So this is the same equation written in different ways. Now this equation in either form needs to be memorized for your examination. Now if you look, the units for velocity are meters per second, the units for time are seconds, so the units for acceleration are going to be the units of velocity divided by the units of the time, so it's going to be meters per second divided by seconds, which is written as meters per second squared, or ms minus 2. Now you can write it as m slash s slash s, m slash s squared, or ms to the minus 2. Now any of those are fine to use in an examination and in real life. Now a fundamental rule of physics states that an acceleration can only be caused by a resultant force. So only a resultant force can cause an object to speed up or slow down. Only a resultant force can cause an object to change direction. Now, no resultant force, no acceleration, it stays with the same velocity, so it's the same speed in the same direction. And that fundamental rule of physics is called Newton's first law of motion, and all objects obey Newton's first law of motion. Now, as we said before, acceleration is the change in velocity over time. So velocity is a speed with a direction. So if you change your speed, you change your velocity, you accelerate. So if an object changes speed, it will change its velocity, it's accelerating, which can only happen when a resultant force is acting upon this. Now this is the most commonly thought of method of acceleration in the real world. Now a negative acceleration in this context could mean a decrease in speed, but there's another way you can accelerate, because like we said before, velocity is a speed with a direction, so if you change direction, you change velocity, you accelerate. Now again, what requires to do this? You need a resultant force to act on an object. Now in this context, a negative acceleration could be the object moving in an opposite direction, which means that just calculate a negative value, you can't actually understand if a negative value means a change in direction or a change in speed. Now you can only look at which one it is by looking at the information in the question. So to produce either a change in speed or a change in direction for an object, a resultant force is needed. Now, like we've just mentioned before, in our velocity time graph, when you divide your y-axis by your x-axis, you find the gradient of the line in the graph. So the gradient is the velocity, the y-axis, divided by the x-axis time. So it's velocity over time, which is acceleration. Now, the other thing you've got to be aware of is you can work out an area under a curve by doing the y-axis multiplied by the x-axis. So in this time, the area under the curve is the velocity times by the time, which is the distance travelled by an object. So to calculate the area under the curve, to work out the distance travelled for an object, you split that shape under the curve into triangles, rectangles and squares, and you can then use this to work out the area of these shapes. So step 1, what do? Split them into shapes which you can work out the area of easily. So squares, triangles, rectangles are the most obvious ones. So I'll split this shape into a triangle and a square. You work out the area of the square, so from GCSE maths, area is length times by height. You can work out the area of the triangle, again, GCSE maths, a half times by length times by height. Then you work out the total area by adding the two values with each other. So let's look at an example question. So look at the following velocity time graph of a journey of an object. Work out the distance travelled by this object in the journey. So first thing you do, split up your area under the curve into rectangles and triangles. Then work out the area of the rectangle. So it's going to be 10 times by 8 height times by base 80 meters. You can then work out the area of the first triangle, a half times by height times by base, a half times by 10 times by 4 equals 20, and then work out the area of the second triangle. Area equals a half times by height times by base, so it's a half times by 10 times by 2, which is 10. Then what do to find your final answer? You add up all three. So 20 plus 80 plus 10 is 110 meters. That's the distance travelled by the object. So it can again be shown in the following example. So split up your object into rectangles, squares and triangles. Use GCSE maths to work out the area of each shape, then add the total together. So that indicates that we've got to use velocity time graphs to work out the distance travelled by an object. But we can also get velocity time graphs with a negative section. So what do we do here? So what does the negative section mean for the object? So like we mentioned before, a negative when dealing with a vector such as velocity means the object is moving in the opposite direction to when it's in the positive values. So the distance moved in one direction is the positive section, and the distance moved in the opposite direction is the negative section. So we've got a positive displacement and we've got a negative displacement. Remember, distance travelled is the scalar quantity. It has no direction. It is just a value, whilst the displacement is the vector quantity. It does have a direction. So negative and positive displacements are in opposite directions to each other. So if there's a negative section, how do you work out the total distance travelled? Well, you work out the total distance travelled by just adding up the areas, of both positive and negative sections, and that gets you your distance travelled. Why can you do this? Well, distance is a scalar. It has no direction quantity, so you just add the two values. But how do you work out the total displacement? Well, to work out the total displacement, you would subtract one area from the other area because displacement is a vector. So as a result, it does have a direction attached to it. So one has to be a positive and one has to be a negative. So when you add up these values, you're actually subtracting one of them because we'll say area 2 here is a negative. So adding a negative is in fact subtracting. So what have we learned in today's lesson? We've learned that velocity is a speed in a given direction. Acceleration is the change of velocity per second, and it's given with the unit meters per second or meters per second squared. We can calculate the average acceleration by doing the change in velocity over time taken, and deceleration is the change of velocity per second when an object slows down. Now, the acceleration of an object can be calculated from the gradient of a velocity time graph. The distance travelled by an object or the displacement can be calculated by the area under a velocity time graph, and students should be able to draw velocity time graphs of measurements, interpret lines and slopes to determine acceleration, interpret enclosed areas in velocity time graphs to determine the distance travelled or the displacement, and if you're struggling to calculate the areas by using GCSE maths equations, you can also count squares to work out the total area. So if we have learnt in today's lesson, we can define what velocity is, we can describe in both words and mathematics what acceleration is, and we can construct a velocity time graph and we can interpret it. I hope you've enjoyed today's lesson, looking at velocity time graphs, looking at acceleration and looking at velocity, and I hope you have a lovely day.